Hello, everybody. We are back with another visual pattern challenge. And boy, is this one a doozy. Here is step one of our pattern. Here's step two. Here's step three. Here's step four. And your challenge would be to predict the number of blocks in step number five. It's going to be a lot. That's what I'll say off the bat. And then if you can do that, can you possibly predict the number of blocks in step 43? And can you write an equation that would be used to express the number of blocks in any step at all? So that's the challenge. This is a really hard one. So even if you only get the number in step five, I think you should be pretty happy with that. But if you'd like to take the challenge on, pause the video, give it a try. Okay, so there's some interesting different things about this pattern that I'm noticing right off. First of all, it's three-dimensional. And that makes me think maybe we're going to have a cubic function. We're going to have an x cubed in here somewhere. And when we analyze the numbers, there's a trick we haven't used yet to determine whether something is a cubic function by the number. So we'll give that a try today. But let's see if we can look at this, understand what's going on visually, and use that knowledge to try to get a number for step five. Let's see. So what I'm noticing here is that there are two like spots on the top, two little top pieces. Here they're just one block, and then here they're 2 by 2 by 2 cubes, and here they're 3 by 3 by 3 cubes, and so forth. And then there's this base underneath them. So I'm going to think about those parts separately. And look, let's see, the base is 3 blocks there, and here it's 2 by 6, and here it's 3 by 9. Oh, I think I see what's going on. So let's think about the cubes on the top first. I think they're just the step number cubed, but then there's two of them. So this is 2 times 1 cubed. This is 2 by 2 by 2 cubes. This is 3 by 3 by 3 cubes, etc. For 4 by 4 by 4 cubes. So here I'm expecting I'm going to have 2 5 by 5 by 5 cubes. And so I'm going to write that as 5 cubed. So that's these two bits on the top. And then the base, I think the base is just the step number wide. Here it's 1 wide, 2 wide, 3 wide, 4 wide. So I'd expect the base to be 5 wide here. And then the length, yeah, the length looks like it's 3 times the step number. So this is 3 times 1 would be 3, 3 times 2 would be 6, 3 times 3 would be 9. Yeah, that's working out. So in step 5, it would be 3 times 5 or 15. So those are the pieces for step 5. Let's see, 5 cubed, 5 times 5 is 25, times 5 again is 125. So we've got 2 of those, plus this base. Let's see, 5 times 10 is 50, and 5 times 5 is 25, so that's 75. All right, so 125 and 125 and 75. So 125 and 125 is 250 plus another 75, and we're going to have 325 already in step 5. So I think that's my prediction for step 5, 325 blocks. This pattern is growing really, really fast. I'm pretty sure it's cubic, but let's verify that with the numbers. So I'm going to make a chart here with the step number and then the number of, I guess I was calling them blocks. So in step 1, we just have 5 blocks to begin with. In step 2, we go up to, so what is that? So that's 8 and 8 and 12. So is that 28? And in step 3, we've got 27 and 27 and another 27. So is that 81? And in step 4, we've got the 16, or sorry, the 4 cubed, that's 64 and 64, and then the bottom 64, 64, and 48. I think that's 176. And then for step 5, we said 325. So you can see these numbers are getting bigger very rapidly. So we start at 5 and we're already at 325 by step 5. So we can expect step 43 to be a pretty darn big number. Let's, as we usually do with this numerical analysis of a pattern, let's take the differences. So 28 minus 5 is 23. And 81 minus 28 is that 53. And 176 minus 81, 95. And 325 minus 176 is 149. Okay. Now you'll notice they're not the same. So we know this is not a linear pattern, and that makes sense. It's growing way too fast for this to be a linear pattern. If it's a quadratic, where its highest term is x squared, we would expect the difference of the differences to be a constant. So let's find those. So this is just 30, and this is 42, and this is 54. So the highest term is not x squared. The differences here are not a constant. We can take the difference of the difference of the differences, and if that third order level of differences is a constant, then we know the highest term is x cubed. So that's 12, and aha, that's 12. Look at this. So we have a constant in the third order differences. That means this is a cubic function. So x cubed is going to be involved in here some way. And I think it's actually pretty easy to see from the way this is arranged how that's going to be. I think we can make an equation by using our visual intuition here. So we have the two cubes on each of these, and they just are the step number cubed. So I think that part of it is always going to be 2 times the step number cubed. So I'll write that as 2x cubed. And then there's the base. And when we were figuring this out before, we said it was the step number by 3 times the step number. So that would just be x times 3x. And if we multiply that together, it's 3x squared. So plus 3x squared. And I think that's actually it, because that's all I'm seeing in the pattern. Let's just double check to see that this works with at least a couple of these, although I'm pretty confident in this. So in step 1, this would be 2 times 1 cubed plus 3 times 1 squared. That's 2 times 1 plus 3 times 1, 2 plus 3, that's 5. So that checks out. Let's just try it with step 2. So 2 times 2 cubed plus 3 times 2 squared. So 2 cubed is 8. So 2 times 8 would be 16. And 2 squared is 4, and 3 times 4 is 12. So we'd get 16 plus 12, or 28. Yes, that's what we got. Now, you can try this out with these other steps, but I feel pretty confident about this right now. The last thing we have to do, however, is figure out step 43, and that can be done with this equation fairly easily, way more easily than trying to draw out whatever pattern this would look like at step 43. So let's plug in those numbers. So y equals 2 times step 43 cubed plus 3 times step 43 squared. So what is 43 cubed? These are really big numbers. So I'm going to have my 2, and that is 79,507. And then 3 times 43 squared. 43 squared is 1,849. I think I've got that memorized at this point. And let's see, 2 times 79,507 is 159,014. And 3 times 1849 is 55,47. And we add those two together, and I'm getting, you may want to double check this math, but I'm getting 164,561. That is a lot of blocks. And that is our answer for the number in step 43. Well, how did that go? I think that was an incredibly difficult challenge. It's the first time we've seen a cubic function like this. Were you able to figure out the number for step 5? If so, feel good about yourself. Were you able to go beyond that? Amazing. Let me know. Thanks, everybody.